In this video I'm going to illustrate how to calculate the atomic concentration and also how to calculate uncertainty in the atomic concentration when the atomic concentration has been calculated using regions applied to photoemission peaks. I've already constructed the survey spectrum and regions on the survey spectrum. So here we see all the different photoemission signal that we think represents the sample, and we then can see the regions that are on the quantification parameters dialog window, because all these regions and the data all relate to a single VAMAS block. So selecting the VAMAS block, that will be part of generating the report, but based on what we see in the active tile, all I have to do is press the calculate error bar, and what will happen is a Monte Carlo calculation will be performed that will estimate the range of possible values for these data given the amount of noise in the data. So the first thing that one ought to make sure is that these data really are conforming to Poisson statistics, because that will be the assumption by which these uncertainties are calculated. So let's now go back to the raw data without any regions, and let's see if we can estimate the uncertainty, and that will be based on performing a regression calculation, that is a linear calculation of a background that goes through the data. So every variation above and below the background can be used to calculate the residual standard deviation, and for Poisson statistics we'd expect that to be about unity. And yes, indeed, for this interval of energy, the residual does suggest, and the shape of the residual suggests, that we have a good estimate in terms of signal and noise based on the Poisson statistics. So we can now go back to the data and apply the calculation of the error bar based on this VAMAS block using the calculate error bar button, and then the uncertainty, the standard deviation in the area, is calculated, and that must be performed before we go to the standard report and request a text report based on regions. I've made use of a configuration file that includes the error bar field. So here we see now the uncertainty in the atomic concentration that has been calculated from the survey measurement. So if we go back to our data, and this time I'm going to use a file that has been created from that survey measurement, in the sense that each one of these intervals of signal has been extracted from the survey measurement using the toolbar button that says spectra from regions. So I set up a set of regions on the survey measurement that extended beyond the interval over which I would like to define regions, and then using this toolbar button I could create from the survey measurement these individual VAMAS blocks representing the signal we see here. So now the problem is, how do we calculate the uncertainty? Well, we could go through and we could calculate for each individual spectrum using the calculate error bars. However, if I select these data and then right click and select the region error bar calculation as the only option on the propagate section of the browser operations, press OK, and we will see here the calculation of the standard deviation for this one, but it will also happen for all of these selected VAMAS blocks. So here we see the uncertainty that's been calculated for the silver 3D. So once we have these calculations performed, we can go to the report spec page, and selecting all of these VAMAS blocks that all have the error calculated, we can now use the regions button again, and once again we end up with the uncertainty in the atomic concentration that is now calculated from a set of individual VAMAS blocks.